part 2 of lecture 4.7. We're going to start talking about the Pythagorean Theorem. Now, the Pythagorean Theorem is very explicit to a right triangle. A right triangle is a triangle that contains a 90-degree or right angle. The longest side is across the right angle is called the hypotenuse. And we usually label that as C. The two shorter sides are usually labeled A and B. Now, the Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So visually what that means is taking a right angle, or a right triangle, the hypotenuse squared, so C squared, will equal the sum of the other two sides squared, so A squared plus B squared. So the Pythagorean theorem is C squared equals A squared plus B squared. But we don't really want to know what C squared is. We always kind of want to know what C is. So if we take the square root of both sides, we'll get down to what C is. Remember, square rooting a square will cancel them out, leaving us just with the original number, in this case, C. So let's try to use our equation to solve some problems. So I have a couple of examples here. A couple of right triangles. Remember, right triangles, this only works for right triangles. So I have a right triangle that has one side of 3 meters, the other side of 4 meters, and the hypotenuse is unknown. So I can use the C equals the square root of A squared plus B squared to solve for the problem. So let's just run through that problem right now. C squared equals A squared plus B squared. Well, it doesn't matter if I label this A or B. I'm just going to say that the 3 meters is A. So C squared equals 3 squared plus 4 squared. Well, 3 squared is 9. 4 squared is 16. So now 9 plus 16 equals 25. But that's what C squared equals. So I want to take the square root of both sides. Once I take the square root of C squared, that leaves me with C. And the square root of 25 is 5. So C equals 5 meters. Okay, let's try another triangle. This time with the lengths of 5 and 7 inches, and I don't know what my hypotenuse is. So again, C equals A squared plus B squared. So A is 5 in this case, and B is 7. So C squared equals 5 squared plus 7 squared. 5 squared is 25, 7 squared is 49. So C squared equals 46. C squared equals 74. But we don't want to know what C squared is. So we take the square root of both sides. C equals the square root of 74. We're going to plug that into the calculator and we're going to get an approximation. Because remember, 74 is not a perfect square, so we're not going to get a perfect number coming out. But we'll get a good approximation. So C will be approximately 8.6 inches. Now you might be wondering, when would I ever use this math? Well, think about all the things that create triangles in life. I mean, a ladder leaning up against a wall, a flagpole and the length of its shadow on the ground, and if you connect those 2 points, you get a line. 2 roads that are going perpendicular to one another. Well, if you made another road, how long would that road be? I mean, there are a lot of things out there that you might apply this concept. So let's take kind of a simplistic view of it. Let's say we do have a ladder. It's leaning up against the side of our house, and it goes up the side of the house about the 6-foot point. And the bottom of the ladder, for safety reasons, is 8 feet away from the wall. How long is the ladder? So if we drew a picture, here's our side of the house, and our ladder goes up to the 6-foot point. So the length there is 6 feet. The length of the bottom of the ladder is 8 feet away from the house, so we know the length of that quote-unquote leg of the triangle is 8 feet. We need to find out the length of the ladder, which is our hypotenuse. So c squared equals a squared plus b squared would work perfectly fine. We're going to plug in our information. So c equals the square root of 6 squared plus 8 squared. Well, 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. Square root of 100? 10. So our ladder is 10 feet in length. So again, you may never ever work with ladders, but you might start looking around the world and seeing triangles where you've never seen them before, and you can actually calculate, like, what if you don't know the height of a tree? You know, what if you don't know that? But maybe you set up a ladder to touch the top of the tree, and you know the distance between the bottom of the ladder to the tree, then you could figure out how tall the tree is. So you don't always are looking for the hypotenuse, maybe you're looking for the height of something. There's one last thing I want to share in this video with you, and it's called the spiral of roots. And I find it a very elegant spiral and very intriguing spiral because of how it is built. So here's our spiral, and we can keep going and going and going. And it actually makes a beautiful, what I think it looks like, a nautilus shell, that little sea creature. Anyway, I find it very beautiful, and mathematically it's so, I don't know, there's just something about it that I find really beautiful. So here's how it's created, and it's created using square roots. Now you might ask why. Well, we start off with a right triangle, and the sides A and B are the length of 1. And we figure out the hypotenuse. Well, 1 squared plus 1 squared is 2. Square root of 2 is the square root of 2. So the length of our hypotenuse is the square root of 2. Now, using the square root as one of our legs, we use our other leg to make a right angle, and that is the length of 1. So here's our new right triangle, and we're going to figure out the hypotenuse. Well, the square root of 2 squared plus the square root of 2 squared plus 1 squared is 2 plus 1, which equals the square root of 3. So the length of this side is now the square root of 3. And we keep repeating that. So again, from the square root of 3 length, which used to be our hypotenuse, it becomes our next leg of our right triangle. We create a right triangle. Here's our right angle. That length is 1. Again, we use our math. And now, it's the square root of 3 squared plus 1 squared. Well, square root of 3 squared is 3, plus 1 is now 4. That's the square root of 4. Well, we can also call that 2. So our length is now 2. And if we were to do this again, make a right angle, length of 1. Now our sides are 2, 1. What would our length of our hypotenuse be? Square root of 5. So it keeps building and building and building. I find it very elegant and very, well, I'm math inclined, so maybe that's why I find the beauty in it. But anyway, I just thought I would share that with you, that now that you understand what the square roots are, that you can actually build one of these spiral of roots yourself. So until next time, be seeing you.